What's going on, Algebros? In this video I'm going to show you how to derive the library function called the square root function. First of all, it's called the square root function because of how we operate on the inputs. Any specific value of x that we choose to plug into this function is going to require that we take the square root of it. So we're going to start there, and you'll notice in this table of values that I've picked some strategic values of x. First of all, we're not going to pick any negative value for x because we can't take the square root of a negative and expect to be able to plot that in the coordinate plane. In other words, we don't plot outputs that are imaginary in the coordinate plane. Alright. You also notice that the x values happen to be numbers that we can easily take the square root of. Alright, so let's start with x equals 0. To find the y value, we'll have to plug it into our function, which requires us to take the square root of that. And the square root of 0 is 0. It gives us our first point, 0, 0. Next, the square root of 1, which is 1. So our next point is at 1, 1. Then we do the square root of 4, which is 2. So our third point is at 4, comma 2. Then the square root of 9, which is equal to 3. So go over to 9 and go up 3 units, like a G unit. Alright, and of course, if we wanted to use different values of x, or values larger than 9, maybe your next one might be 16, since the square root of 16 is pretty easy to evaluate. But of course, we're not just restricted to numbers for x that are perfect squares. I mean, we would still have to consider taking the square root of something like 0.5 or 1.75, so on and so forth. So what I'm getting at here is that there's more to this graph than just these few points. We're going to go ahead and sketch or infer the rest of this graph based on what we do have. This graph's going to start at 0, 0, and it's going to slowly increase and hook off to the right and continue doing so up towards positive infinity. Alright, so now that we have its graph constructed, let's go ahead and look at the deets. The smallest x value that's present on this graph is the smallest value of x that we could plug into the function, which is 0. Alright, the starting x value, in other words, is at 0. We'll include that. And because this graph continues increasing, hooking off to the right forever and ever, that would mean that we're using all values that are larger than 0 on the x-axis as well. So bracket 0, comma infinity. The smallest y value on this graph is 0. We'll include that. And because this graph is kind of creeping its way up to positive infinity, not only is 0 part of this graph, but any value that's larger than 0 on the y-axis is going to serve as some sort of y-coordinate on the graph as well. So bracket 0, comma infinity, parentheses by default on the infinity. Now for answering whether or not this function's even or odd, well, the visual approach, we'd have to check for two types of symmetries. The first type of symmetry would be y-axis symmetry. Now think to yourself, if you were to take that graph, which is entirely in quadrant 1, and reflect it across the y-axis, there wouldn't be anything for it to land on top of. Alright, so for that reason, this graph does not have y-axis symmetry. In other words, this graph is not, or this function, I should say, is not even. Now, if you were to see if this function is odd, we'd have to reflect it over the y-axis and then reflect it over the x-axis. Alright, after doing both reflections, you would see that this part of the graph that's being reflected across the y and the x-axis wouldn't have anything to line up with down here. So for that reason, this function isn't odd either. This is actually an example of a neither or neither function. Okay. For an analytic approach, we'd have to compare three expressions. The first being f of x, then f of negative x, and then negative f of x. Of course, f of x is just the square root of x. And if we were to look at the expression for f of negative x, we'd see that we'd run into some problems. Alright, since x is assumed to be any number from 0 to positive infinity, placing the negative in there gives us something that isn't real. Alright, in other words, this is kind of an invalid expression if we're expecting the outputs to be real numbers. Alright, so this right here, because of the domain, we could say that it's not really defined. Alright, so let's say not defined. As for negative f of x, we just put the negative in front of the square root. Okay, and even visually, you'll see that neither of these expressions are equal to each other. They all look a little bit different. So we wouldn't be able to say that f of x equals f of negative x, nor would we be able to say that f of negative x is equal to negative f of x. So there's some analytic evidence that this function is a neither function as well. Now as for increasing, the graph starting at 0, 0, if you trace your finger starting from 0, 0 along the graph, you'll see that your finger goes up, albeit at a slow rate, but your finger would just continue to rise on your paper indefinitely. So for that reason, this entire graph represents something that's increasing. All right, and the x values that cause the graph to increase in this way are from 0 to positive infinity. In other words, this function is increasing entirely. So for that reason, there wouldn't be anything that is decreasing on, so we'll just put NA. All right, and that's all the info for the square root function. Thanks for watching. Let me know if you have any